Before the break, we say that we assume all members are under tension at the beginning. Okay, this point we assume all members are under tension at the beginning. So this is the idea. Okay, this is the idea. What you do, what you should do. What you do is this. In a free, in a free body diagram, these member forces point away from joints. So in a free body diagram, when you draw a free body diagram of a joint, like this, all member forces should point away from joints. Okay. If you forget the first point, it's fine. But what you should do in drawing the free body diagram, remember to put all member forces away from the joint. So if you are looking at joint C, so all forces should be away from joint C. Member forces are these three, for example. Member forces like TAC, TCB, and TCB should be away from joint C. Okay, for example, if we in this diagram we are talking about joint C. So the member forces, which are TAC, TCB, and TCB, these three should be away from joints. So the direction should be away from the joint. So you write it down, and then I will show you another example. You write down first, and I will show you another example. I'm sorry, I think I missed one force. I think this one we have a force P here. Please help me write it down. Okay. I forgot this one. So when you draw free body diagram, remember the force that goes out. Let's go back to the. I will come back in a minute. So let's go back to the last one. So for example, when we did rigid body A, when we did joint A, is this this force TAD is away from A, and this TAC is also away from A. Okay. So always away from a joint. Always out, and going out. So in the inverse that in what you do in the free body diagram, member forces, these three, for example, these three should point away from joints. 往外画，记得。So if you are fine with this, and then we go to the next page. We go to the next page. So if you haven't finished writing it, please go on. After you finish that, we go to the next page. Now we go to sample problem 6.1. So we have a chart like this and determine the forces in each member. So I will only do one. And so how many members do we have here? So we have this shape and then two members here. How many members do we have? Remember that we do not have A, B, C. A, B, and B, C are two members. Remember, A, B, and B, C are two members. And so we have 1, 2, 3, 4, 5, 6, 7. We have 7 members. Okay. First of all, we have 7 members. Now, and then we have the free body diagram. And we first draw the free body diagram of the whole truss, as in chapter 4. So so you draw a free body diagram of A, B, C, D, E, and then you do your, and then you have, and then we have the forces, and of course you have the dimensions. Now, so go to textbooks to go to figure 1 of page 309 for the whole figure. So we first work on the whole truss as a rigid body, and we have here we have CX and CY and E forces here. These are support forces. Now, after we draw the free body diagram, then we consider A, B, C, D, E as a rigid body, and we have these equations. We have these equations. So we have summation m equal to 0, summation mx equal to 0, and summation my equal to 0. I think you can read this by yourself, and if you have homework that you can do this yourself. These are the things from chapter 4. So if you are not, if you have not worked on the homework on chapter 4, so go home and do them. And the next one is the force in each member. Now, for each member, so we can we take one joint. We take one joint at a time. So we have here we have A, B, C, D, and E. So, for example, if we take out AB, we take out AB, and we take out AD, so we leave it. We have joint A. So we draw the free body diagram of joint A. So we have point A here, and in the problem, we know that we have 10 kilonewton going down at joint A. We have 10 kilonewton. In the problem, we know we have 10 kilonewton going down at joint A. So what are the members connecting joint A? We have, let's go back to the figure and I will come back. So, and if we look at joint A, which rods connect to joint A? We have AB and AD, right? If we look at joint A, so we have one joint, we have AB and we have AD. So we have, therefore we have, let me write it with like this. Now, as we talked about in the last hour, that we remove AB and we put one force here. We take away AB. We take away not AB and we put a force AB, TAB. Now, so should this force go to the left or go to the right? TAB. Should this force go to the left or go to the right? So TAB is going to the right. And this one is theta. And this one is, so TAD goes to the bottom right, TAD. Remember, these forces are away from the joint. Well, why? If you get this wrong, then the rest will be wrong. If you get this right, then usually you'll be fine. And for these tangents and for this theta, we know tangent theta is equal to 4/3 or 4/3. Now, and we have a point, so we have equilibrium equation. So if you don't know what to write, what do you write first for equation? Because we have equilibrium. So you don't know what to write, and what should you write here? Equilibrium, then summation fx or summation f equal to 0. So we have summation fx equal to 0. And summation fy equal to 0. Remember to write these two. Remember to write these two. Now we have so we have TAB plus TAD cosine theta equal to 0, and Fy equal to 0. We have minus 10 kilonewton minus TAD sine theta equal to 0. So we will arrive in, we will get TAB is equal to plus 7.5 kilonewton and TAD is equal to minus 12.5 kilonewton. Now, one of them is, you can write it down first. Take your time. So one of them is positive and one of them is negative. What does it mean by positive and negative? So and some of you may remember what I've said. So if it is positive, it means it is in tension. And if it is negative, if it is more than 0, if it is negative, it means it is in compression. So when you write your answer, that if you follow the book, that it is TAB is equal to 7.5 kilonewton, and you put the T here, and TAD is 12.5 kilonewton, and we put a C here. Sorry. Give me a minute, give me a second here. Have I talked about 挂号的英文是什么？ OK， 好we put a bracket here. It's okay. So we after that we get TAB and TAB, and we get after we look at joint A, we get TAB and TAB, and then we take another joint to we look at another joint to work on. For example, we look at joint D. So we look at, if you look at joint D, we have joint D here, and what do we have? Which members are connected to? Connected to is 连接啊 connected, connect to 连接啊 Which members are connected to joint D? We have AD, and we have DB, and we have DE. Remember that, and these are fatal. Sorry, and these are fatal. Remember that the arrows that you always put it going out. Even if you have, for example, TAD is negative 12.5 kilonewton, it is the best way is to write TAD is equal to minus 12.5 kilonewton. So you will not do things. You can always do things in the correct way. And this is TBD, and this is TDE. Remember that all the forces are going out. If it is negative, then just write it as negative. But in a three-body diagram, all forces go out, go away from the joint. Okay, go away from joint. 往外画吧。So, and then you work on, then you have summation fx equal to 0 and summation fy equal to 0. Okay, so you work on again and again. So as I've said, it is not difficult. as I've said before the break, it is not difficult. But 很烦啊，真的很烦。英文怎么说 ？Annoying, okay. Annoying. You can say annoying, or I would say use another word. It is cumbersome. 庸常。Okay, so this is not difficult, but it's annoying or cumbersome. And so do your homework, and I'll give you like 3 or 4 questions, but you can always work on more. So for today, I will. I think I will work on one more problem. So take your time to draw this. Remember, all forces are going out. I think now and take your time and. Any problems up to now? If you're okay, then I will go on to the next problem. So page textbook problem 6.12. So we have a truss like this, and by analyzing equilibrium at points A and C, determine the tension in the BC, AB, and CE. So this determined. Now, and so the structure looks like this, and we first draw the free body diagram of A to H, and so we have point A and point H. Sorry, because we have a roller joints here, so we have AY here, and at point H we have H, X, and HY. I hope this clear to you. 知道为什么是这样子画吗？在这上面，我假设大家知道。So because we have a pin joint here, and we have a roller joint here. Can you see them? So this is a pin joint, and this is a roller joint. So on the right we have 2 forces, and on the left we have 1 force. So for rigid body analysis, so we consider the host, we consider the equilibrium of whole structure. So we have we will get H X equal to 0. AY is 4 kilonewton going up, and HY is 4 kilonewton going up. Wait a minute. Give me a minute. Give me a minute and. Now we have the support forces, right? And we have the support forces, and we go to point A and point C. So for the point forces at point A, we have joint A here. We have joint A, and we have how many members connect to how many members connect to joint A? That is AB and AC. And we have so we have TAB and TAC. So we have TAB and TAC, and we have theta here. Do we need to draw other forces? Are there other forces here? So of course we know we have TAC and we have TAB. Anything else? We look at the original problem. We look at the problem here. We have AY and we have 1 kilonewton there. So we have 1 kilonewton here, and then we have AY here. AY is 4 kilonewton. And so we have I will leave it to you to write it, and we have tangent theta is equal to 3/4 or 3/4. And you go on to work on the summation fx equal to 0 and summation fy equal to 0. And then I will leave it to you to I will let you to write these equations. I'll post it on iLearning in a couple of days time. I'll leave it to you as a homework when you go home, that you can write this down. And it's okay. So this is point A. Remember that you put all the forces here. Problem number 1 of your seniors is that they forget that forces are going out. Problem number 2 is in a free body diagram that we have, like here we have 4 forces, but sometimes your seniors only have 3. So if you do this wrong, and then everything afterwards will be wrong. It's okay. So we have 4 forces here. Next we have point C. So anybody wants to? So I'll draw point C here. For point C, for joint C, we have C here, and then which members are connected to joint C? We have AC, AC, and BC, and we have CE. So we have T, TCB. I'm sorry. We have TAC and TCE here. Now, and so I think I've drawn all the forces. And we have, and of course, we have the usual summation Fx equal to 0 and summation Fy equal to 0. And we have TCE minus TAC equal to 0. And for Fy equal to 0, we have TCB equal to 0. Because TAC will be known. So you copy this down, and I will talk about. Take your time. Now, for this equation, you will get that TAB is equal to minus 5 kilonewton, and TCE is equal to plus 4 kilonewton. Remember that if you get the minus sign, it means this is compression. And TCE is plus 4, so it is in tension. So if you get TAB is equal to minus 5 kilonewton, minus means compression, and the plus means tension. And TBC is equal to 0. And in the textbook, that it is called a zero force member. And some professors would care about this a lot, but I do not. So this is the answer.